All right, here we're looking at section 9.6, and our learning targets for today is to use inverse trig ratios, and then we're going to be solving right triangles. And we'll talk about what each of those things means here as we get to them. So our first example is to determine which of the two acute angles has a cosine of 0.5, right? So I'm given a triangle, and I can see here that this is one of my special right triangles, so that can come into play later as well. But first we are trying to figure out which of the two angles has a cosine of 0.5. So first I have to find the cosine of each acute angle. So I see that the cosine of A is the adjacent over the hypotenuse, right? So here's A, here's my adjacent over the hypotenuse, so the square root of 3 over 2, which is approximately 0.8660, which is not 0.5, so let's check the angle B. So I find the cosine of B, right, which is the side adjacent over the hypotenuse, which is 1/2. So I can see that the acute angle that has a cosine of 0.5 is angle B. So I've used some of my ratios to help me find some information about my angle measurements. And that's what I use with these inverse trig ratios. So we're saying that angle A here is an acute angle. So we're looking at the inverse tangent, inverse sine, and inverse cosine. So if the tangent of A equals x, right, so tangent of A is equals x, so I've got that ratio figured out, then the inverse tangent of x is equal to A, the angle A. Same thing with sine and cosine. So what we use these inverses for is we're really using the inverse functions to help us find the measures of angles based on what side lengths I have, right? So if I have the hypotenuse, or if I have the adjacent side or the opposite side, that helps me figure out which of the inverse functions I'm using. So I use my regular functions if I'm given the angle, and it helps me find a side length. I use my inverse functions to help me find the angles when I'm given the side lengths. That's really where the difference comes into play and when I'm going to use each one. So let's look at this example. So let angle A, angle B, and angle C be acute angles. Use a calculator to approximate the measures of the angles to the nearest tenth of a degree. So I always, when I am dealing with tangent and these trig ratios, I always kind of write my SOHCAHTOA, just so I can always kind of remember. It helps put back in what sides of these triangles that I'm looking at. So let's look at angle A. So I can, if I know the tangent of A is 0.75, I can take the inverse tangent of that to help me find my angle measurement. And then I can also use the sine of that for part B, right? So I know that the sine of B is 0.87. So to help me find what B is, I would use the inverse sine, which gives me 60.5. And then same for cosine. If I know the cosine of C is this, 0.15, I can take the inverse to find my angle measurement. So really what I'm doing is I'm undoing what I've already done, right? So I know when I'm solving for something and getting it by itself, I have to undo the math that's already been done to it. So here, that's what I'm doing. I'm using the inverse operation to find the angle measurement that I'm talking about. So now here's your first monitoring progress. Use this triangle to kind of help you figure out which angle we're talking about. And here's some more monitoring progress. Now you're given some of the ratios, and you're going to be using those inverse trig functions. Now we're going to be solving these right triangles, right? That's our second learning target for today. So to solve a triangle, that means you find all of the pieces of it. So you have to find all the angles and all the sides. So I can solve a right triangle, right? And remember, we're dealing with right triangles right now, when I know either of the following. If I have two side lengths, I can use the Pythagorean theorem to find the third side length, and then I can use some of my inverse trig functions to find the angles. I can also solve right triangles if I know one side length and one of the angles, because then I can use my trig functions and my inverse trig functions to find the rest of the pieces that I'm looking for. So I have to have either one of these two bullet points in order to solve my triangle. So let's look at an example. So it asks me to solve the right triangle, and we're going to round our decimal answers to the nearest tenth. Well, I see I'm given two of the side lengths, so I know that this is a triangle that I can solve. So I'm going to use the Pythagorean theorem, right? Because again, I know it's a right triangle, so a squared plus b squared equals c squared to find the hypotenuse. So I plug in the things that I know and I substitute, and I know that c is going to be the square root of 13. And I was told to round my decimal answers, so I'm going to use a calculator to do that. I'm not asked for exact answers here. So now I'm going to find angle B. And it doesn't matter which angle I find first, A or B. I already know C, right? Because that's my right angle. So I pick the other angle and I can find B. Well, I'm going to use my calculator and I'm going to use the inverse tangent. And I'm using the inverse tangent because I am given both of the legs. I had to find the hypotenuse, so in order to just not use any of my possible mistakes from before, I'm going to use the information that I was already given. And since I was given the legs, the opposite and the adjacent, I'm going to use the tangent function. So I use the inverse tangent, and I know that tangent is opposite over adjacent. So I take the inverse tangent of 2/3, and in my calculator I end up with a 33.7 degrees. So then I have to find angle A. That's the only thing that's still missing. So I know that A and B are complement angles, right? Because if I add them together, they equal 90 degrees. So I can just simplify and subtract this 33.7 from 90, and I get that angle A is approximately 56.3 degrees. So here's my final sentence that I've solved my triangle. So C, and you'll see that side lengths are small letters and angles are big letters, and that actually is very important. So side length C is approximately 3.6. The measure of angle B is approximately 33.7 degrees, and the measure of angle A is approximately 56.3 degrees. Now make sure you keep this in order of, like, when I'm dealing with angles, I have to actually write angle A, and I use my capital letter, and I use degrees. We want to be as precise as we can be when dealing with these values. So now here are two that I want you to try. And in both of these examples, you see that you are given two of the side lengths of your triangle, so then from there you can solve and find the third side, and then use our trig functions to find the measures of the angles. So now here's our next example where I'm given one side length and I'm given one of the angle measurements, and I have to still solve my right triangle. So in order to do that, I have to find the other two sides and the third angle. So first I want to use my trig ratios to find the value of G and H. So if I'm going to find H first, I know that the sine of H, right, so the sine of my 25 degrees is the opposite over the hypotenuse. So I end up, and then I simplify and substitute what I know. So I know the opposite side was H, 13 is my hypotenuse, and I multiply both by 13, and I use my calculator to end up with 5.5 is H. So now I want to find the cosine of H. Right? I'm using still the same angle that I was given to find the adjacent side because I know cosine deals with the adjacent over the hypotenuse. So I plug in what I know and I simplify and I end up with the G is approximately 11.8. And again, you'll see that my side lengths are lowercase letters. So now I just have to find the measure of the angle that I was missing, which is easy enough to do because I know H and G are complementary angles. So I take 90 and I subtract what I already have and I end up with 65 degrees. So in this triangle, H, the side length H is approximately 5.5, the side length G is approximately 11.8, and the measure of angle G is 65 degrees. So now I know the lengths and the measures of all three sides and all three angles. And that's what I'm doing when I'm solving these triangles. So let's look at kind of a real world example. So your school's building a stage. Okay? The stage will be 30 feet long, as shown here, from front to back with a total rise of 2 feet. And again, I always draw out my triangle if I'm not given a drawing already. You want to rake, so the angle of elevation, and remember an angle of elevation is if I'm looking and I go up, how far am I looking up? The angle of elevation is going to be 5 degrees or less for safety. Is this stage within my desired range? Well, so now I see I'm given two side lengths of my right triangle and I'm trying to find the angle. Does this work? So I'm going to use my inverse sine ratio. And let's explain why I know it's going to be sine. So first off, I always kind of write my SOHCAHTOA, right, just to help me remember what I'm looking at. So I see here's my angle over here, and I see I have the hypotenuse, because it's across from the right angle, and I have the side length that's opposite. So I'm looking for the opposite on hypotenuse, which leads me to sine. So that's how I decide I'm using the sine ratio. And I see I'm trying to find the angle, so I know I'm going to be using the inverse sine ratio. So I set that up. The inverse sine ratio, and sine is opposite over hypotenuse, is equal to approximately 3.8. So the rake would be 3.8 degrees, so that is less than 5 degrees. So I know that this will work. So now go ahead and look at these ones. You're asked first to solve this right triangle, and remember, to solve the triangle, you're looking to find all of the pieces that are missing. One thing when we're naming triangles, you'll see here that my points, my vertices, are the capital letters. The side across from each angle is named with that same letter. So this would be side Z, and remember that we deal with lowercase when we're dealing with side lengths. This side down here would be side length X, and this is going to be side Y. And so this is just kind of a naming convention when we're dealing with triangles. You always go with the side across from that angle. So try these two and see how you can do and if you're following along. So we're going to look at our learning targets again. Our first one was to use inverse trig ratios. So remember, we use these inverse trig ratios when we're trying to find angle measurements and we're given the sides. Then we use some of this to solve our right triangles. And when we're solving right triangles, we need to have information on all three side lengths and all three angles. And we know that one of those angles is a right angle, so I just have to find the measures of the other two. So now that we've looked through these learning targets and practiced some examples, go ahead and work on your homework for 9.6.